This is the review for test unit 4 on similarity. Number 1, complete the similarity statement for the two similar triangles given. So one of the triangles is given here with WBA, WBA, and the other triangle is going to be the overlapping triangle, which is inside. And in order to make sure they're similar, I'm going to find the corresponding angle to this angle down here. Now, 120 is underneath, which means right next to it needs to be a 60 because these are a linear pair. And now I see that 60 and 60, the two corresponding angles are equal, and of course they share the angle W at the top, so these are similar by angle, angle. So I'm going to now name the similar triangle as W, Y, X. Okay, number 2, determine if the two triangles are similar. If the triangles are similar, state the reason. Side-side-side similarity, side-angle-side similarity, or angle-angle similarity. If the triangles are not similar, write not similar. So I'm going to test for part A. I need to make sure that the ratio of the sides is equal. So I'm going to take the 8 and the 4. I know I have to match up the 8 and 4. They're both the smaller numbers out of the two sides. So 8 over 4 must be equal to the other two sides, 18 over 9. And when I simplify these, I get 8 over 4 is 2, and 18 over 9 is 2, and I know that these are equal. So this is similar by side, angle, side. They have the same angle measure, and the angle is connecting the two sides together. It's connecting the red and the green. So this is side, angle, side similarity. Part B, 3 sides. So I'm going to again match up all 3 sides. I need to make sure that the ratio of the sides is equal. So I'm going to start with the smallest side on the triangle to the left, which is a 24. And that side is going to match up with the smallest side on the triangle to the right, which is the 15. And that needs to be equal to the next biggest side, which is 32, over the next biggest side of the other, which is 20. And that needs to be equal to the biggest side, 40, over the biggest side of this triangle, 25. And when I simplify these in my calculator, 24 over 15, I get about 1.6. 32 over 20, I get about 1.6. And 40 over 25, I get about 1.6. So these are similar by side, side, side. Okay, number C, all I'm doing is going, by the angle marks. So I have an angle here and an angle here, and the same angles marked in the other triangle. So this is similar by angle, angle similarity. Part D, okay, similar picture to number 1. I have overlapping triangles, and these parallel lines going across these two sides mean that I can put corresponding angles to be congruent. And we know this from chapter 2. Corresponding angles are congruent when I have parallel lines. So those two angles I know are going to be congruent. And the two triangles share this angle to the side, or if the triangle was right side up, that would be the angle on the top. So this triangle, these two overlapping triangles are similar by angle, angle as well. All right, part E, more angles. Now I have two 90s, and then I have a 60 in one triangle and a 30 in the other. So I want to find the missing angles here because it might be a 30. So when I do 180 minus 90 minus 60, what do you know? I get 30. And if I try the other angle here, when I do 180 minus 90 minus 30, I get 60. So all three angles are equal, which means this triangle, these two are also similar by angle-angle similarity. Okay, moving on to part F. I have two sides with an angle in between. The angle has equal measures in both triangles, that's good. So now I just need to check the sides. So I'm going to do 18 is the smaller of the two out of 24, and then I'm going to match up 18 with 12 because 12 is the smaller out of 12 and 16. 18 over 12, and I want to check and see if this is equal to 24 over 16. And when I simplify these in my calculator, 18 over 12, I get 1.5, and 24 over 16, I get 1.5. And because these two are equal, I know that this is similar by side, angle, side, similarity. Each triangle has two sides and one angle, and they're in the same position. Okay, part G, I have three sides, so I need to match up sides again. I am going to start with the smallest number, just like I have been. 8 needs to match up with 6. And if these are similar, that should be equal to 12 over 9. The other side is also going to be 12 over 9. I don't need to check it twice, but I just want to write it so that we know. So when I divide 8 over 6, I get 1.3. And when I divide 12 over 9, I get 1.3. So that means this other 12 over 9 is also going to be 1.3. So all of the sides are equal, the ratios, and so this is similar by side-side similarity. Number 3, what is the scale factor of triangle ABC to triangle QRS? The scale factor is the ratio of the sides. So I'm going to make sure I'm matching up the congruent sides. 8 is the smallest side of this triangle, and 6 is the smallest side of that triangle. So 8 over 6. And I want to reduce this. If you go in your calculator and type this in as 8 divided by 6, and then you push the math button, and then you push enter twice. So 8 divided by 6, math, enter, enter, and that will give you the reduced fraction of 4/3. And if I checked the other sides, I would see that I get the same number because these are similar. 9 divided by 6.75. And if I did, again, 9 divided by 6.75, math, enter, enter, the calculator would give me 4/3. And if I've checked the last side, 12 over 9, would also give me 4/3. Okay, so the scale factor here is going to be 4:3. This is the same meaning as writing it as a fraction, but it's just sort of a different way to write it as a ratio with this colon in between the two numbers as opposed to writing it as a fraction. Number 4, look at this triangle. Which triangle is similar to the given triangle? So I need to check each of these choices and see which one has all of the sides giving the same ratio. So I'm going to match up the two smallest sides. I'll start with part A, and I'm going to do 3.1 divided by 6.1. So I'm taking 3.1 divided by 6.1, and that gives me 0.508. And if I try the next side, 6 and 12, this is exactly 1/2 or 0.5, and that's not the same as 0.508. So A is not going to work for me. I'm going to try B now. I'm going to match up the smallest sides. So I have 3.1 over there, and I'm going to match it up with 3.72. And in the calculator, that gives me 0.83. And now I'm going to try the next side, which is 6, and that's going to match up with the 7.2. And the calculator, that gives me 0.83. I'm going to check the last side for good measure. So 7 is going to go with 8.4. And this also gives me 0.83 in the calculator. So it looks like B is going to be my answer choice. I probably should check C and D to make sure that those ratios don't match up. So I'll just kind of do this quickly. If you checked 3.1 from the main triangle with 1.55, this would give you 2. Math, enter in your calculator. Or you don't have to for this one, it would just give you the 2. And then I'm going to match up 6 over 3.5, and that gives me 1.71. So C is not an answer choice. And then D, 3.1 over 9.1 gives me 0.34. And 6 over 18 gives me 0.33. These are close, but they're not exactly the same, so D is not my answer choice either. Okay, so the correct answer is B. Number 5, find the scale factor and missing variables. I'm going to redraw each of these triangles because these are overlapping. So the top triangle, I'm going to draw in red. This has a 6 on the left, an 8 on the right, and an X on the bottom. And the big triangle I'm going to draw in blue. Now this has a 26 on the bottom, and the whole right side, part is 8 and part is 12, so the whole side is 20. And I'm going to do the same thing on the left. Just like I added the 2 parts on the right to get 20, I'm going to add the 2 parts on the left to get 6 plus y. So there's my 2 triangles. Now to get the scale factor, I want to match up 2 sides that have numbers. I don't want to use a variable for this because the scale factor needs to be a fraction. So I'm going to take the 2 right sides, 8 over 20. And if I simplify this in the calculator, you're going to get 2/5. All right, part B, find x. So I'm going to take the scale factor, 2 over 5, and I'm going to set it equal to the corresponding side with x. So x is the bottom, and the bottom of the big triangle is 26. You can set x over 26 equal to 8 over 20, and you'll get the same answer, but your numbers are just a little bit smaller if you work with the scale factor. So I'm going to cross multiply, and you end up with x equals 10.4. Okay, and then for y, I'm going to do the same thing. I'm going to take the scale factor, but this time I need the 2 corresponding sides with y. One of the sides is on the left, 6 plus y, and the side in the small triangle that goes with that is 6. So far I've been doing the small triangle on top, the big triangle on bottom, so I need to be consistent with that. So I'm going to do 6 from the small triangle on top and 6 plus y from the big triangle on the bottom. I'm going to cross multiply, and I get 2 times 6 plus y equals 5 times 6, which is 30. And I'm going to distribute, and I get 12 plus 2y equals 30. Subtract 12 from both sides, 2y equals 18. And finally divide by 2, and you get that y equals 9. Number 6, again, find the scale factor and the missing variables. The scale factor for ABC, similar to EFD. So I'm going to make sure I'm matching up congruent parts. The bottom BC is going to go with FD because they're both the last two letters. And then AB is going to go with EF. And 8 is going to go with Y. Okay, so I'm going to use the two sides that have numbers for the scale factor. And it's 12 over 24. And if I simplify that, I get 1/2. Okay, to find x, I can set up the proportions. Some of you might just be able to do this in your head by looking. If I know that the small triangle is half the size of the big triangle from the scale factor, then that means x has to be half of the green side, which is 9. If I set this up, it would be 1/2 equals x over 18. You could cross multiply, and you would get 9. Okay, and then for y, I'm going to use the red sides, and again, you could cross multiply and set this up. 1/2 equals 8 over y, or you could just kind of reason through this. If the smaller triangle is half of the bigger triangle, well, 8 is half of what? 8 is half of 16, so y is 16. Number 7, using the diagram at the right, solve for x and y. So again, I'm going to find the two sides that are congruent. I like to use colors, so the hypotenuse of the big triangle is going to be equal to the hypotenuse of the smaller triangle. And then I have that AB is going to be congruent to FD. Again, if you get confused, just look at the similarity statement. It will tell you which parts match up. And the last side, BC equals DE. Okay, so I can just pick any of the sides that have numbers. It doesn't matter if you pick 6 over 3 or 10 over 5. You'll get the same number either way. But I'm going to solve for x first. So I'm going to do 10 over 5 equals 8 over x. And I'm going to cross multiply and solve, or you could just recognize that the bigger triangle is twice as big as a smaller triangle because 10 is 2 times 5. So x has to be 4 because 8 is 2 times 4. All right, for y, I'm actually looking for an angle now. Okay, and I don't know that it's equal to 30. Again, using colors might help if you're having a hard time with this, because the 30 is between the red and the green sides, which means the 30 is actually the angle up at the top. So in order to find y is the angle between the blue and the red sides. So if I find that, I'm going to find y by subtracting the other two angles from 180. So 180 minus 90 minus 30, and I'm going to find that y is 60 degrees. Number 8, using the diagram below, solve for x. Again, anytime I have this overlapping triangle picture, I'm going to redraw them to the side. So I have the small triangle on top, which has a 6 and an x plus 2. And then I have the bigger triangle, the whole thing, which has a 10 on this side. I know because this whole arrow is going across the whole side. Now I need to find this other whole side though. And when I have two parts, in order to get the whole side, I'm going to add them up. So I'm going to add x plus 2 plus 5, which if I combine like terms is going to be x plus 7. I'm going to erase this so we don't get confused. Okay, so that's where the x plus 7 came from. All right, and now to solve for x, I'm just going to set up a proportion. And I'm going to use the two corresponding sides. 6 over 10 equals x plus 2 over x plus 7. I need to cross multiply, so 6 times x plus 7 equals 10 times x plus 2. I'm going to distribute 6x plus 42 equals 10x plus 20. I'm going to start combining like terms, so I'll subtract 6x from both sides. I always move the smaller number of x's towards the bigger number of x's. Equals 4x plus 20. And now I'm going to subtract 20 from both sides. And you get 22 equals 4x. Divide both sides by 4. X equals 5.5. Number 9, given ABC, triangle ABC is similar to triangle DEF. Find the perimeter of DEF. So I'm going to start by finding the missing sides. 18 is going to go with 7.2. And that's got to be equal to 12 over EF. Now I'm going to cross multiply and solve for EF, and you get that EF is 4.8. Okay, now I'm going to do the same thing with the other side. 18 over 7.2 has to be equal to 9 over DF. Cross multiply, and you get that DF equals 3.6. Now the problem asked for the perimeter. The perimeter is when you add all sides. It's the distance around, all the way around the triangle. So to get the perimeter, I'm going to add all the sides of DEF, 7.2 plus 4.8 plus 3.6, and I get 15.6. Now there is a second way to do this problem. It's a little bit quicker. So I'm going to just show you to the side here. Another option is to set the scale factor equal to the ratio of perimeters. So if the sides have a certain ratio, the perimeter of the two triangles is going to have the same ratio. So I'm going to take the sides that I know, which is 18 over 7.2, and I'm going to set it equal to a ratio representing the perimeters. So the perimeter of the big triangle, I'm going to work down here for a minute. Is 18 plus 12 plus 9, adding all the sides of the big triangle, and I get 39. The small triangle I don't know, right? So the 39, 18 came from the big triangle, that's on top. So the perimeter of the big triangle will go on top. The perimeter of the small triangle I don't know, so I'm going to put it right there, little p. And when I cross multiply and solve this, you actually still end up getting that p is 15.6. 0.6, which is the same answer I got before. Okay, so two ways to do this. Whichever way seems to come easier to you or make more sense, you can use. Number 10, which triangle is similar to the triangle in figure 1? I have two angles given here and I want to find the third angle. So I'm going to start by subtracting the two angles I know from 180. And I get 74. So this bottom angle there is 74. Okay, now in part A, or in choice A, I have an 81 and a 75. And those angles don't match up with figure 1. 75 is wrong. So A is not going to work. B also has a 75. It has a 25, which matches up with my 25, but the 75 again is wrong. Part C has a 74 and 81, which means if I subtracted from 180, I would get 25 also at the top. So those are going to be similar. D only has one angle, which is not enough information. So your choice here is going to be C. Number 11, which triangle is similar to the triangle in figure 1? This is just like the one we did a minute ago, but I have a side now. So I'm still going to find this third angle by subtracting from 180. 180 minus 25 minus 74, and you get 81. Okay, now I'm going to make a note of where the 5 is. Where is the side on this triangle? The side is between the 25 and the 74, or if you want to think of it this way, the 5 is across from the 81. So in the triangle that's similar, needs to have the same position. The side has to be across from the 81. So in choice A, here's the 81. The side is not across from 81, it's next to 81, so A is not going to work. Part B, here's the 81. It has the same angle, 25 here, and the side is across from 81, so that's good. I'm going to check the other two answers just to make sure. Here's the 81. The side is not across from 81. It's next to 81, so C is not going to work. And again, D, here's the 81. The side is not across from the 81, so D is not going to work. Your answer choice here is B. Number 12, triangle LMN is similar to triangle PQR. Which of the following sets of side lengths could be the lengths of triangle LMN? So the sides from PQR, I'm going to list them from smallest to biggest, since that's what my choices are, all smallest to biggest. And I need to pick the choice that has the same ratio of the sides. So 6 to 3 is half, right? But 7 to 4 is not half. So A is not a good choice. B, same thing, 6 to 3 is half, but 7 to 4 is not half. So B is not a good choice. C, 6 to 12 is times 2. 7 to 14 is times 2. And 9 to 18 is also times 2. So it looks like that's going to be my answer. If you checked D, you would see that it doesn't work. Not the same ratio. Okay, 13, given that C and W are equal, which condition proves BAC equals SRW? So BA is going to go with SR. AC is going to go with RW. And CB is going to go with WS. Okay, so the angle is between the red and the blue sides, which means it's in the same position, so that's good. The only choice with similarity for proving similar when you're mixing angles and sides is side, angle, side. So I need to make sure that the choice I pick is giving a correct ratio for the blue side and the red side. These have to be the side, angle, side. So the blue and red are on either side of the angle. So part A, I have BA over SR, and BA is not the blue or the red side, right? Neither is SR. So A doesn't work. I don't want to use the green side, just using the red and blue, just the two sides on either side of the angle. Part B, AC over RW equals BA over SR. Again, I'm using the green side and I don't want to do that. C, AC is the blue, CB is the red. So I'm using the blue side over the red side, and RW is the blue side, and WS is the red side. So this looks like it's going to work. I'm going to check D just to make sure. D says BC, which is the red side, over RS, which is the green side. I don't want to use the green side. Okay, and then BA is the green side and SW is the red side. So this actually doesn't work for another reason, which is that the proportion is not equal, right? If you have red on the top of one, the red has to be on the top of the other, so D does not work. 14, if the triangles are similar, give the reason. Side, side, side similarity, side, angle, side similarity, angle, angle similarity, or not similar. Fill in the triangle names that are similar. All right, so part A, I have three sides. I'm going to check with all the proportions being equal. So I'm going to start with the small side here, 4 over the small side here, 2. That should be equal to the next 16 over 8, which should be equal to 18 over 9. All of these equal 2. So the ratio is the same. This is similar by side, side, side similarity. Now I just need to match up the sides. So RST equals MPQ. If you're using colors, this writing the similar triangles part is a lot easier. Okay, part B, I'm going to fill in the vertical angles here. Angles across from each other are always congruent in that X shape, vertical angles. So these triangles are going to be similar. They each have two angles that are congruent. So these are similar by angle, angle similarity. And the congruent statement ABC equals E, or is similar to triangle EDC. Part C, I have two angles in each triangle. They're not equal right at first, but I want to find the third angle because the third angles might match up. So when I do 180 minus 115 minus 35, I actually do get 30. And when I find G at the top of the other triangle, 180 minus 35 minus 30, I get 115. So these are similar by angle, angle. Okay, JKL is congruent or similar to FGH. Okay, part D, I have two sides with an angle in between. I have the 4 and I have the 6 with an angle in between. And on this side I have a 2 and then I have the 3, but the angle's not in between. The angle has to be between the two sides. This is not similar. This is not in the right position for SAS. Part E, I'm going to check that all the sides are the same ratio. Starting with the smallest, 6 over 9 should be equal to, the other 6 over 9 should be equal to 7.2 over 10.8. I'm going to check this in my calculator. 6 over 9 is 0.6. 6 over 9 is 0.6. And 7.2 over 10.8 is 0.6. So these are similar by side, side, side similarity. And I'm going to match up here MNP should be congruent to QRS. You also actually could do S bar Q because the triangles have two sides that are the same. 15, use the word bank to list two pairs of similar triangles in the diagram below. Some items in the word bank will not be used at all. Okay, the first thing I notice in this picture are the parallel lines. The parallel lines help with similar triangles because they give corresponding angles. So now I just need to see which triangles come from these parallel lines, and it's these diagonal angles right here, triangles. Okay, so these are going to be similar because they have the vertical angles equal, and then they're going to have the corresponding or alternate interior angles equal. So now I just need to find them over in the word bank. I see a DFE right here. DFE should be congruent to CF. Oh, BFC. BFC. Okay, and now I'm going to look for another pair of triangles. The other pair is also going to use the parallel lines. Another triangle that uses the parallel line as one of its sides is right here. And the big triangle then is going to be the whole picture. Okay, so they share an angle here on the side, and then they're going to have corresponding angles in the corner. So the red triangles are the second pair, and that's going to be ADE is congruent to ACB. Similar to, sorry, excuse me. These are similar triangles. Okay, 16, determine if triangle ABD is similar to triangle AEC. I'm going to first find the midpoint of AC. The midpoint is halfway. AC, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 12 squares. So the middle, the midpoint needs to be 6 from one of the sides, which is right here. And that point is 0, -5. Now I want to find the midpoint of AE. This one's a little bit trickier because it's going diagonal. So I'm going to find the rise and the run numbers, or the distance numbers for A to E. The bottom is 12. And this side is 6. In the middle, the midpoint has to be half of that. So half of 12 is over 6. And half of 6 is up 3. And I should land on the line, which I do. So the midpoint of AE is 1, -3. Okay, is DAB. DAB is this angle right here. Is that equal to EAC? And EAC is also that angle right there. So this is yes. The ratio of AB to AC. Ratio of AB to AC. I found the midpoint and it was at B. So that means AB is half of AC. So the ratio is going to be 1 to 2. Just like 1/2, but we're writing it a little bit differently. The ratio of AD to AE, similar. The midpoint is D, right? So that means AD has to be half of AE. Also, this is going to be 1 to 2. If the triangles are similar, then ABD is similar to AEC by, well, I had the angle at the top, and then I found the two side ratios. So that's going to be the side, an angle, and a side on the other side. Okay, next one, determine if ACE is similar to BCD. I'm going to find the distance of AC. I'm going to count how far up and over I have to go. This is 8, then this is 4. So I'm going to use Pythagorean theorem. 8 squared plus 4 squared equals c squared. And in your calculator, you should get square root of 80. Okay, CE. Also going to count how far down is 2, how far over is 8. I'm going to use Pythagorean theorem again. 2 squared plus 8 squared equals c squared. And for this, I get square root of 68. Okay, next I'm going to find BC. BC is up 4 over 2. And 4 squared plus 2 squared is 20. Square root it, you get square root of 20. DC is down 1 over 4. 1 squared plus 4 squared is 17, and I'm going to square root it. Okay, is ACD equal to BCD, right? The blue and the green angles I just drew are the same, so this is yes. Are the triangles similar? I have to make sure the ratio of the sides are the same. So A to C, AC over BC has to be equal to the whole side on the bottom, CE, over the small sides, CD. And if I try this in the calculator, square root of 80 over square root of 20 and square root of 68 over square root of 17, I do get 2 for both. So they have the same ratio. So the triangles are similar. And again, I used 2 sides with an angle in between, so these are similar by side angle side similarity. Number 18, a tree casts a shadow of 42 feet, while a 6-foot tall person casts a shadow of 5 feet. Find the height of the tree. All work must be shown. So I need to set up a ratio here because these are similar triangles. And I'm going to just set one fraction is going to be the height, and the other fraction is going to be the shadows. So I'm going to do the tree on the top. So I'll do the tree height over the person's height, and I'm going to set it equal to the tree shadow over the person's shadow. When I cross multiply, you're going to get that x equals 50.4 feet. Okay, number 19 is the same, except I don't have a picture. So I'm going to draw the triangles here. Tree casts a 13-foot shadow, while a 5-foot tall person casts a shadow that is 1.5 feet. How tall is the tree? It's the same exact problem, so I'm going to draw these triangles again. Okay, so the tree height I don't know. The tree shadow is 13 feet. The person is 5 feet tall. And the person's shadow is 1.5 feet tall, or 5 feet. Okay, so again, I'm going to do both of the heights in one fraction and both of the shadows in the other fraction. So x over 5 equals 13 over 1.5. Cross multiply and divide. X equals 43.3 feet. Okay, number 20, a flagpole casts a 20-meter shadow, while a 1.5 meter person casts a shadow that's 1.2 meters long. How tall is the flagpole? This is the same problem, but I have a flagpole now instead of a tree. The flagpole height is what I'm looking for, so that's x, and the shadow is 20 meters. Now I have a person. The person is 1.5 meters tall, and their shadow is 1.2 meters long. So again, I'm going to set up a ratio of the heights, the flagpole over the person, and a ratio of the shadows, the flagpole over the person. Cross multiply and divide, and x is 25 meters. A person places a mirror between herself and a building. When she is 3 meters away from the mirror is 17.5 meters away from the building. She can see the top of the building in the corner of the mirror. If she is 2 meters tall, how tall is the building? So I have a person here, and I have a building, and there's a mirror between them. So that kind of means they're facing each other. So here's the building, and here's the person. Okay, and the mirror is between them. Oops. Mirror. Okay, and I'm going to fix these triangles because actually they should be coming all the way to the mirror. So the triangles are actually going to be touching. Okay, so there's one, and here's the other. All right, so now I'm going to label the picture. The girl is 3 meters away from the mirror, and she is 2 meters tall. The mirror is 17.5 meters away from the building, and the building height I don't know. So the triangles are not facing the same direction, but I'm still going to set up one fraction is the height and one fraction is the distance to the mirror. So I'll do the girl over the building of height equals the girl over the building of distance from the mirror. And we're going to cross multiply and solve, and x is 11.6 meters. Okay, last problem, 22. Using the diagram and expression bank below, create the setup that could be used to solve for x and create the setup that could be used to solve for y. Each item in the expression bank can be used more than once. So we don't have to solve here, I'm just setting up as if I were to solve. If I redraw these triangles, I'm going to have x here, 2y on the bottom, and 2x there. And now I'm going to draw the big triangle down here. I'm going to add the two sides for the big triangle. So this is x plus 3. The bottom is 3y plus 6. And this side, again, I have to add the two parts. This is 2x plus x plus 4. So when I combine the terms for the blue triangle, 2x plus x is 3x plus 4. X plus x is 2x plus 3. All right, so now I'm going to do red over blue. So the red triangle to solve for x, I could do x over 2x plus 3, the side over the side, equals the hypotenuse, 2x over the hypotenuse of the other one, 3x plus 4. You could also, because these are parallel, set up one part over the other, x over x plus 3, the top part of one side over the top part of the bottom part of the same side equals the top part of another side over the bottom part of the other side, and that would be acceptable as well. For y, I'd have to use the two bottom parts because that's the only ones with y. 2y over 3y plus 6, and I can set it equal to any of the sides with x. So I could do x over 2x plus 3, or 2x over 3x plus 4. Now because the green part is the bottom, the whole bottom over the whole bottom of that big triangle, I have to set it equal to the whole side of one over the whole side of the other. So for part B, you cannot do one part over another part like I did with part A in blue. You can't do something like that for part B. Okay, good luck. If you have any leftover questions, make sure you bring them to your teacher.